Okay, so these are the solutions for the 20 questions for term 3, and this is week 1. So I'm going to go through these in full, make sure you understand how to do them, and that if you didn't get them right, that you write out your corrections fully. Okay, so we're looking at solving this equation here. Big problem is this 6 at the bottom of the fraction. So I want to get rid of that, and in order to cancel that I need to multiply by 6, but I multiplied both sides by 6. So let's get a red one. If I multiply this side by 6, okay, I have to multiply this side by 6, but what we need to remember is that all of that side gets multiplied by 6. So what I'm left with over here, when these two are cancelled out, is 8x plus 32. So we have the 8x plus 32 there. And on the other side, everything's multiplied by 6, so we get 6x plus 30. Okay, then we just go through solving an equation where I've got x on both sides. So I look for the smallest number of x's, which is 6x, and I subtract those, but I subtract it from both sides. Okay. Okay, so that leaves me with 2x here plus 32, and on the other side I've just got 30. Okay, and then I want to leave the x's on their own, so I want to get rid of the 32, so I'm going to subtract 32 from here and from here. So we need to remember that 30 take away 32 is going to be negative, so that's minus 2 left there and 2x left on this side. Okay, and then you're going to divide both sides by 2 because there's 2 x's, and minus 2 divided by 2 is minus 1, so x is minus 1. And you can always check your answers, because if I put it back in, 8 minus 1 is a minus 8. If we add that to 32, that's 24. Divide by 6 is 4, so we get 4 on this side, and minus 1 plus 5 is 4, so it works. So similar with this one, okay, so this time we have got a 3 at the bottom of a fraction, but it's only on the bottom of the x, so I do need to be a little bit careful. I am going to do the same process. I am going to start by multiplying to get rid of that 3, but what I need to remember is everything on this side gets multiplied by 3, and everything on this side gets multiplied by 3. So I'm putting the brackets around to remind me to multiply everything. So if I do 3 times this, x over 3, that just leaves me with x. But then I've got to do 3 times the negative 4, which gives me negative 12. Okay, on the other side, I've got 3 times x gives me 3x, and 3 times negative 10 is negative 30. Okay, then as before, I'm looking for the smallest number of x's, which is x this time, so I'm going to subtract x from both sides. The reason I choose the smallest number is just to avoid difficulties with negative numbers. Okay, so if I'd taken away 3x, I'd have ended up with a negative on this side, so I don't want that. So always look for the smallest number of x's to subtract. So what am I left with on this side? X take away x, and then I've got negative 12 left here, equals 3x take away x is 2x, minus 30. Now I want to leave the x's on their own, just so there. So I need to get rid of this negative 30, so I'm going to add 30 to both sides. Okay, so minus 12 add 30 is 18, and we get 2x there, and minus 30 add 30 cancels, so now I've got 18 is 2x, so again I'm going to divide by 2 because I want to find 1x, so we get 9 equals x, or x equals 9. Okay, again we can check that by putting it back in. So 9 over 3 is 3, and 3 subtract 4 is minus 1. We've got minus 1 on this side, and then on this side 9 subtract 10 is minus 1. So minus 1 equals minus 1, it works. Okay, it doesn't tell you what to do here, okay, but the idea for both of these, question 3 and 4, is to simplify. Okay, so we're going to start by multiplying out the brackets. So I've got 4 times 2a is 8a, and 4 times 4b is 16b. And then I've got 5 times 2a is 10a, and 5 times 3b is 15b. Okay, just going to... Okay, so now I've got to collect the like terms together. So I've got 8a plus 10a is 18a, and then I've got 16b plus 15b is 31b. That's done. Okay, so remember, you can add the a's to the a's, and you can add the b's to the b's. Okay, so for this one, again, multiply the bracket. So 3 times a is 3a, 3 times 4b is 12b. Now here I need to be a little bit careful because it's the minus 5 that I'm multiplying by. So minus 5 times a is minus 5a. Minus 5 times minus 5b is plus 25b. Okay, so minus times a minus is a plus. So I get, again, 3a minus 5a is minus 2a. And then I've got 12b plus 25b is going to be plus 37b. Okay, so again, just check and correct your work for those. Fractions. So we're going to multiply out fractions. When we're multiplying fractions, multiplying mixed numbers, you need to have them as a top-heavy fraction. So I need to turn 2 1/4 as a top-heavy fraction. So 2 wholes split into quarters gives me 8 quarters. I've got 1 more there, so that gives me 9 quarters. And then 2 wholes split into thirds is 6 thirds, plus 1 more is 7 thirds. Okay, now we would multiply the top, multiply the bottom, and then cancel, but don't forget you can cancel before you start multiplying. And we have got a 9 here and a 3 here that have a common factor of 3. So 3's into 9 go 3, and 3's into 3 go 1. So I've cancelled there, which gives me 3 times 7, which is 21. 4 times 1 is 4, so I've got 21 over 4, and then I want to try and put that back to a mixed number. So 4's into 21 go 5 times exactly, with 1 left over, which is 1/4, 5 1/4. So here we're subtracting mixed numbers. So I'm not going to get it into a top-heavy fraction unless I have to. So I'm going to start by looking for a common denominator, which in this case is going to be 15, because that's the lowest common multiple of 3 and 5. So if this is turned, if 3 becomes 15, it means I've multiplied it by 5, so I need to multiply the top by 5, which gives me 10 15ths. So I've got 2 and 10 15ths there. Okay, and I multiplied the 5 by 3, so I've got to multiply the 2 by 3, which gives me 6 15ths, or 2 and 6 15ths. So now I'm going to do subtraction. So if I start by subtracting the whole number part, 2 take away 2 is nothing. So that's sorted, and then I've got 10 15ths, take away 6 15ths is 4 15ths, and that's the end of that question. Okay, so we're multiplying decimals. So to start with, I'm just going to ignore the decimal point and do 121 times 74. So I'll get 4 1s are 4, 4 2s are 8, and 4 1s are 4. Okay, so that's 4 times 121. Now I'm doing 70 times 121, so I need to put the 0 in there. So it's 10 times bigger. 7 1s are 7. 7 2s are 14, so that's 4, carry 1. And 7 1s are 7, add the 1 is 8. And then we're going to add, so we've got, it's 4, 8 and 7 is 15, so 5 carry 1. 4 and 4 and 1 is 9, and 8 goes there. So we get 8,954. But I need to remember that I multiplied this number by 10, and I multiplied this number by 10. So I'm going to have to divide my answer by 10 twice. Okay, so if I divide by 10, it gives me 89.54. And I can check that, because if I rounded these, 12.1 would be about 10, 7.4 would be about 7, 10 sevens are 70, so my answer's in the right region. Okay, dividing decimals. 480 divided by 0.8, I've written it as a fraction to start with, because I know with a fraction, whatever I do to the top, I would do to the bottom, and vice versa. Okay, so I need to make that denominator a whole number. So if I multiply that by 10, that gives me 8, but I need to multiply the top by 10, which gives me 4,800. So what I've got to understand now is that these are equivalent fractions. They're exactly the same number. So now if I do 4,800 divided by 8, so 8 into 48 goes 6, and then 8 into 0 and 8 into 0, so the answer is 600. I don't need to do any more work, okay, because that is exactly the same as that, which is exactly the same as that. So the answer to 480 divided by 0.8 is 600. Question 9. Nice straightforward bid maths. You need to do the 5 times 5 first, which is 25, then add the 2, which gives you 27. 3 times 4 is 12, take away the 3 is 9. Now, question 11 and 12. I don't think we've done this for a while, so we need to make sure that we understand the equivalence ratios for centimetre squared and millimetre squared and centimetre squared and metre squared. So we know that 1 centimetre is 10 millimetres. So if I draw a square and I say, well, this length is 1 centimetre and this length is 1 centimetre, then the area of the square is 1 centimetre squared, because 1 times 1 is 1. But we also know that 1 centimetre in millimetres is 10 millimetres. So it's 10 millimetres times 10 millimetres, and 10 times 10 is 100. So the area is 100 millimetres squared. So the equivalence is that 1 centimetre squared is 100 millimetres squared. Okay? Now, if I'm turning centimetre squared to millimetre squared, how do I get from 1 to 100? I times by 100. Okay, so I need to multiply this number by 100. So 3.5 times 100 is 350 millimetres squared. Okay, so a similar idea with the next one, only it's metres squared. So if I had a square and it was 1 metre by 1 metre, the area would be 1 metre squared. Okay, but I know that there are 100 centimetres in a metre. So to find the area in centimetres, it would be 100 times 100, which is 10,000. Okay, so it'd be 1,0,0,0,0 centimetres squared. So 1 metre squared is 10,000 centimetres squared. Okay, now how do I get from centimetre squared to metre squared, or how do I get from 10,000 to 1? I would be dividing by 10,000. So in this question, I need to do 21,500 divided by 10,000, which will give me 2.15 metres squared. Okay. Question 13, you've got to evaluate 3 to the power 4 times 2 to the power 5 without a calculator. So you could work out this and do long multiplication, and that's absolutely fine. I've just shown you a slightly different way of doing it. It's up to you, as long as you get the right answer. It doesn't matter on the method in this case. So this one, 3 to the 4, well I thought, well actually 3 to the 4 is actually 3 squared times 3 squared, and 3 squared we know is 9, so I've started by saying, well that's 9 times 9 times 2 times 2 times 2 times 2 times 2, which is the 2 to the 5. Well 9 nines we know are 81, and now all I'm going to do is keep doubling. So 81 times 2 gives me 162, and 162 times 2 gives me 324. 324 times 2 is 648, times 2 is 1,296, times 2 is 2,592. So there's the answer, 2,592. Okay, similar with this one. Okay, 4 squared is 16. Okay, so we've got 16 times 2 times 2 times 2 times 2. So start with 16 times 2, and that was 32. Then times 2 is 64. Times 2 is 128. Times 2 is 256. Okay, so question 15. What is the cube root of 216? Now, this is one that you can just learn. Okay, you don't need to know this one, but you might want to just learn all your cubes and cube roots, so that's fine. If you don't know it, remember this is non-calculator, it'll be a non-calculator question. So another way of working it out is actually to sort out your, to do a factor tree and work out what the prime factors are. So I've split 216 down into its prime factors, and you'll see there's 3 2s and 3 3s. So 216 is actually 2 cubed times 3 cubed. So interestingly enough, we're looking for the cube root. We've got a 2 cubed and a 3 cubed. Now because the powers are the same here, I can actually multiply the 2 and the 3, which gives me 6 cubed. So therefore, what number cubed gives me 216? The answer is 6. The cube root of 216 is 6. This one, we're asked to express 1,260 as a product with its primes. Again, factor tree, and you should end up with 2 squared times 3 squared times 5 times 7. If you didn't get that right, you might just want to have a quick look at where my answers came from. So I split into 126 and 10, split the 10 down, and then I just kept dividing by 2 till I got to 63, and then 63 is 9 sevens, and 9 is 3 times 3. Okay, question 17, making x the subject of the formula. So I want to leave x on its own. So this is like solving an equation but with no numbers. So when we were doing equations at the beginning, when I said I had something at the bottom, it meant I had to multiply both sides. So I'm going to multiply both sides by a to cancel that a out at the bottom. Okay, so I end up with a times y on the left hand side and just x on the right hand side because the a's are cancelled. So that's done. I've made x the subject. I've left x on its own. That's fine. So ay equals x or ya equals x doesn't matter. Okay, in fact, we would normally write it as ay, but it doesn't matter if we've got it the other way around. Okay, it means the same thing. This one's slightly different because we want to leave x as the subject of the formula, but x is at the bottom of a fraction and it can't be the subject when it's a denominator. So I need to get that x from being the denominator. So I'm going to start by multiplying both sides by x, okay, because I don't want it as the denominator. So that leaves me with xy, or yx, equals a, but I'm still looking to make x the subject, okay, so I want to leave x on its own, so I need to divide both sides by the y, because I want to get rid of that from that side. So if I divide both sides by y, okay, that leaves me with the x on the left hand side and a over y on the right hand side. Number 19 said, Okay, so we've got to calculate the area of the circle with a radius of 9 and leave your answer in terms of pi. So we don't need a calculator, we just need to leave it in terms of pi. I'm just reminding myself that r is 9. The next thing I need to remember is the formula, which is a equals pi r squared. So r is 9, so I'm going to replace the r with 9, so a equals pi times 9 squared. 9 squared is 81, so it's pi times 81. And then just to tidy it up, we normally write any expression with numbers and then letters, so we'd call it 81 pi. That's all I need to do. Number 20, calculate the area of a semicircle. I'm going to underline that word, semicircle, with a diameter of 30 and leave your answer in terms of pi. So, two things I need to think about here. Area of a circle is pi r squared. I've been given the diameter, so I need to work out what the radius is. So we'd halve it, so the radius is 15, so I've put it there to remind me. We're also looking for the semicircle this time, so I know the formula for a circle. The formula for a semicircle is going to be half that. So the area for this one is half pi r squared. So pi r squared is the whole circle, I want half of it. So I'm putting that in now so I don't forget. So r is 15, so we've got half times pi times 15 squared. 15 squared is a square number that you're supposed to know, so learn it if you don't. It's 225. Okay, I'll skip that step. So 15 squared is 225. And then I've halved it, okay, to give me 112.5. And then again, just to tidy it up, it would be 112.5 pi. Okay, so don't worry too much about your mark at this stage. Mark what you've done. The most important thing is writing out corrections and learning what you couldn't do, because that's how you're going to improve. But send me your marks and I'll just record those. Okay, thank you.